All right, so you would have read the locus of a circle, right? So here's what locus is. If I were to give you, if I were to give you something like this, right? And I said that I am giving you a point, and the point is x, y. That point must be equidistant. So it must be the same distance, let's call that d. It must be the same distance away from this point, let's call that point A, B, right? So the point P must always be the same distance away from A, B, and you allow it to move. If you allow this point to move so that its distance is always D away from AB, it will trace out a circle. That's okay. And we could also work it out and see, right? So for something to be equidistant, right? What does the distance formula? What's the distance between 2 points again? What's the distance between 2 points? Formula. Square root of x2 minus x1 squared plus y2 minus y1 squared. Nice. What's the distance between the 2 points here? Let's call it D, right? What is x2 and x1? X minus A, y2, y1, y minus B. If I square both sides, what will I get? I'll get x minus A squared, y minus B squared is D squared. What does this look like? Equation of a circle, right? This is the equation of a circle with center what? With center AB and radius. In this case, the radius is what? Radius is equal to. Okay with that? So what we're able to show here is that this point moving equidistant from a point AB that will trace out a circle. This tracing here is called a locus, right? So if I ask you to define the locus of a circle, you'll just say a point P that's always equidistant from a point AB. All right? And we should be able to work out locus as well, work out the equation by using the distance formula. All right? Right? I'm using the same notation here. What would happen if we expand? If we expand x minus a squared, y minus b squared, t squared, what you'll get? X squared minus 2ax plus a squared plus y squared minus 2bx plus b squared is equal to d squared, right? If I were to bring these squares together, leave this here, leave this here, and add up a squared, b squared minus t squared, I will have a next equation of a circle, right? Here, you may remember here, center is same thing. Center is AB, and radius is what? What's the radius here? The radius will be t, right? But we have to be able to work it out, right? That's right? You all may remember it in our ADMAS we use FG and CN, right? In ADMAS we probably use F. In ADMAS I think we use this, right? X squared is FG, right? ADMAS we use this version as well, right? And the center was minus F minus G, and the radius was the square root of F squared plus G squared minus C. Right? If you rearrange this to find for D, you'll get the same formula here. Right? So you have this version and you might remember, otherwise it's the same thing. Same concept. I have a minus sign here, that's why it is positive. All right? That's the equation of a circle. Right? Since we own the equation of a circle, let's see if we could find a different way to write this. I can wrap this off? No. This. No? There we go. Um, Yo, it's one here. One, one. Let's see. Let's see. Table. Yeah, table. Right. So, right. When you finish, let's take a look at this circle here. Tangent just like mine, right? Here's AB, so here's the X, and here's Y. Here's XY, here's the X, here's the Y. Right? If you're going to write the circle in a different form again. It's called parametric form. I draw the circle and draw the little right angle triangle in there, right? Ready? So we're going to create something called the parametric equations, right? So far we have two versions. We have this and this, right? We could develop a next equation here. Whatever triangle we have here, right angle, right? And R is the what? Hypotenuse. So R is equal to what? Anybody can tell me what this length is here? This length here is what? X minus A. What about this length here? What is? Y minus B. You recognize the first equation there? I want to show you something here as well. If you were to find sine theta, what you'll get? You all said that this is y minus b and this is x minus c. So sine theta is what? Opposite over hypotenuse, right? Yeah. Can I make y the subject of the formula here? Yes. Carry it across, I'll get y minus b is r sine theta. So y is equal to b plus r sine theta. Okay with that? Now, what is cos theta? Cos theta is adjacent over x minus a over r. Do the same thing, and x is equal to a plus r cos theta. You okay with that? So these two equations here, x in terms of theta and y in terms of theta, these two equations are equation of a circle, right? We call them the parametric equations of a circle. So if I give you this, you should be able to go from here back to here, right? But from this here, can you identify the center and the radius? By just looking at this. Center is here, radius is value here. Sure? Chloe, I'm gonna pick on you. Huh? So look at number one. Looking like a circle. Here's how you just look at a circle, right? These two bars are the same, right? These two bars are the same. We'll prove it in a little while. But you could read off the radius here. What's the radius? 4. And what is the center? 3 and minus 2. Yeah? But Emma, how are we going to go from here? Is a wire. How are we going to go from here to the equation of a circle? Does the equation of a circle have cos theta and sin theta in it? No. So we had to find a way to get rid of that, right? Copy it down and we're going to do that together. Anybody writing here? Copy it down and we'll do that together. Huh? You're almost done. But when your parents making payment, just decline them, they'll say which one was something. Right? Some people like just transfer the bit. Some people. Right? While you're waiting, do my favor now. Convert this into the equation of circles. Right? By the way, this is called parametric. What you're familiar with is called Cartesian. Right? This is called Cartesian. Cartesian has X and Y in it. Parametric has a new variable theta in it. See if you could go from here to Cartesian. And the hint I gave you is you have to remove theta, cos theta and sin theta. I'll show you that now. I'll take my something to finish, right? Right, so I have no iPad again. Where is it? Give it up. I think right? So yes, we can read off center and radius, but if things go bad now and you can't remember, here what you do, right? We can get cos theta. Cos theta is x minus 3 and 4. And we can get sin theta, which is y plus 2 and 4. Right? We can get that. And remember, if we know this, and we know that cos squared theta plus sin squared theta is 1. Remember that? So I could put in cos theta and I could put in sin squared. And then I could square it out. So I'll get x minus 3 squared on 16. Y plus 2 squared on 16 is 4 is 1. When I reach here, what to do? multiply everything by 16. X minus 3 squared plus y plus 2 squared is 6. Right? That is the equation of a circle. All right? We got to be able to go from here to here. Oh, wait, it's at the group. Right? We'll do this in a little while, right? Don't start to tell, we're not doing that as yet. I have one more thing to show you here. Right? Just one thing I want you to remember. This is Form 5 work here. Right, from Form 5, you had to sometimes find the equation of tangent. Right? So sometimes they ask for the equation of tangent. So you remember, equation is y is equal to mx plus c. Right? So how do we find the equation of tangent? Number one, you have to find the gradient of the radius. Anybody remember how to get the gradient of tangent from here? How do you get the gradient of tangent? If you have the gradient of the radius. The negative inverse. So 1 over minus 1 over the gradient of the radius. And then you substitute xy into y minus y1 is equal to m by x minus x. All right? So I'll just give you back the Form 5, right? I just find the equation tangent. Copy that on quick. Right? When we're done, let's try the question in the group now, please. I can't share it, right? So we just have to use that. Right? So if you look at the question there, they gave you what? Two parametric, right? They have circle one and circle two. Convert them to the Cartesian. And we have to find the points of intersection. And actually, why does not place both out? If you're unclosed circle. Right, is not you. To find the point of intersection of two circles. To find the points of intersection of two circles. Right? How do I find where these two circles intersect? What you normally do? Try to make something and substitute in here, right? Make something to subject and substitute. But here's what you can do. To get rid of the x squared and y squared, the next option is to create a new equation by minusing everything. Right? And you'll get a new equation, maybe x plus. So here, 0, 0. Here you will get minus 7x minus 5y plus 7. Right? Right? Everybody okay with that? So when you get this equation now, make x or y the subject and substitute in either one, anyone you want. Then you solve it. All right? So write this down. Step 1. Subtract both equations. Subtract both equations. Step 2. Use the new equation. Use the new equation to substitute. Use the new equation to substitute in either of the equations for the circle. Use the new equation to substitute in either of the equation of the circle. Either one can work, it don't matter. But if you're here, you'll get the same answer. All right? All right. So they gave me equations there. See if you can find part 1 and 2. That part here as well. Try to find here as well. So that's what you can do. That's a question of what time. Right? Picture is right. Right? So can with them. Cartesian form and so. Well, look at that. Going to go now. No. You can see how the sitting on the board, so yeah, okay. I know you get up this, so put my board. You are okay. Right, we talk about that. Yeah, I agree. So, if I'm not that, I'll be on the, so simultaneously. Only things like. We're gonna be two equations.
Yeah.
Yeah. Right, expand them out and then solve. I get 2 points, right? Get the height, it's okay. Right, there are 2 ways you can do it, right? You can expand it out, or anyway, go ahead. Have no, have no or.
Yeah. And that's.
Right?
Right now, that's very first. I can make.
Right, you might recognize that you have the same thing here,
Yeah.
same thing here. So you can minus. Right? So you will end up with x plus 3 squared minus x minus 3 squared. This will cancel and you'll get -4.
Now I'm.
So you'll get x squared plus 6x plus 9 minus x squared minus 6x plus 9 plus 4 is 0. So the x squared might cancel. Right, so we will see the problem with this method just now. Right, x squared cancel, so that means that we're gonna lose a solution. So we'll end up with 12x. The 9 will cancel. Plus 4. So I got x to be minus a third. That's one x solutions.
Yeah.
Minus a half.
Minus that.
Well, bottom.
So go back to
Okay.
then you want
Oh, pretty wrong thing. Wait, see what happened? I lost a solution. Right? I lost a solution by doing this method. Right? Supposed to be 2. Right? So I wouldn't use this, right?
Is it same next slide?
We're saying about 5. Oh, like, anyway, let me expand it out and do it this way, right? X squared plus 6x plus 9. Y squared minus 4y plus 4. Right, so I have x squared plus y squared plus 6x minus 4y, 13 minus 10. Let me make sure I minus nothing wrong, eh? 9, 13 minus 10 is 3. Expand this one here. X squared minus 6x plus 9. Y squared minus 4y plus 4. So I'll end up with x squared plus y squared minus 6x minus 4y. 9 plus 4, 13. So I got minus 3. So I'm minusing equations here. And I will get 12x plus 6 is 0. So x is minus a half, right? Right? So since we have x, we can go back and find y. So I'm putting it back in here, right? Minus a half squared plus y squared plus 6 by minus a half. Right? And we should get a quadratic that will give us 2 answers, right? So we'll get 1/4. So we'll get 1 plus 4y squared minus 12 minus 16y plus 12 is 0. Plus 1. What we got here for y? How much? 3.94. 0.06. So our 2 answers are minus a half and minus a half. So that's okay. All right, last thing. Last part. Part being the question. Still have one more part, eh? Still have one more part. We'll stop after that. I will show you the left, right? So that's after the next. I went back to show you ellipse now. So that means.
You know, class you.
Yeah. Yeah, that's next week. No, I advise the next week.
So how Maggie?
So yeah, so yeah, that's next week. Thank you, Saturday.
And then you got yes.
Thank you, Saturday. This is supposed right? Well, we came out of finish already, you know.
We, I'd love to go.
How much days you feel months? On something? Oh yeah, two parts. Brief amount. Hello?
Next
Right. So the last question is a Lucas type question, right? Yeah. So I want some help here. I'll pick on somebody to help me, right? Here's what they said. They said that the point P is the point P moves so that the distance from a fixed point 0.3 distance from a fixed point 0.3 is 2 times that from a fixed point 5.2. Where do I put P on the diagram? The point P moves at is distance from the fixed point here is twice the distance from here. So can I put P here? So the distance from here to here is twice the distance from here. Right, so watch here. Right, Nathan? So watch here, right? So if I give you a point like this, and I tell you to find the equation that this will trace out, it always has to be 2D away from here and 1D away from here, regardless of how it moves. However it moves, right? We need to find the equation of that. What we gonna do? If you remember the Lucas question that we did, right? What was the equation that we used? Distance, right? Yeah. So is it possible to find D here using that formula? And then multiply it by? See what happen now? Find D, see what you get. Then find 2D, see what you get. Right? Use the distance formula. Use the distance formula here, use the distance formula here. And then let's see what equation we end up with.
I know. If you been
Right, so your first equation is what? Your first equation, x minus 5 squared, y minus 2 squared. Second equation, x minus 0 squared, y minus 3 squared. All right, so we have two equations and I can substitute D in here. I would like you to simplify that out, please. Substitute D in here and it will turn into an equation that's familiar to you. Hurry up, substitute D in here, Lucas. Let's see what you got. Yeah. Over there. Cannot identify it, it should be something I recognize.
No. Which one do you know?
Right, so we will end up with 2 by the square root of x minus 5 squared plus again it's square root there, Adam. Again it is square root. Yes, you like that. So put 2 by this,
Oh, yes.
square everything, right? So you'll get 4 by x minus y minus 2 squared is equal to, and then you simplify it out.
Yes.
What is this here? What is it like, Anya? I'll give familiar. A circle, if you divide by 3. Circle, right? Alright? So therefore it's a circle. Right? And you could write the center on the radius. But okay with that?
Yeah.
Hey, John?
Oh.
The boy center on the radius.
Right.
Everybody okay with that? So anytime we targeting, anytime we have to work out Lucas type questions, you have to use this formula here for distance, right? A nice graph will help you. Alright? Alright, we'll stop there. We're supposed to do ellipse what? Right? You have a circle and you have an ellipse. Ellipses look like this. Right? We have to take a look at ellipse. So we'll do that next Saturday. We have 3 days out. So we'll continue with that. Alright, so that's it.
Ahora,